Yes, let us speed up the questions now. The next question goes like this. They had given you RO minus and RS minus, and they asked you what is the nucleophilicity ordo and what is the basicity ordo, and ask your brain the first question, do they belong to same group or do they belong to same period? Your brain immediately and fastly, instantaneously tells they belong to same group. And nucleophilicity in a polar protic solvent down the group, nucleophilicity increases. Therefore, RS minus is a strong nucleophile than RO minus, and basicity down the group decreases. Therefore, RO minus is a stronger base than RS minus. And I already told you numerous times, wherever you see polar protic solvent, you must immediately recognize it affects, it causes the salvation. There is one more question. The question goes like this: CH triple bond acetylide ion and CH2 double bond CH minus. So between these two, which is a strong nucleophile? If you look these two, in both cases, in both of these example, carbon has the negative charge, but whereas hybridization of carbon is here sp, here sp2, and you already know electronegativity of sp is greater than sp2. Therefore, the carbon with this negative charge is far happier than the carbon with the negative charge here. This carbon is not as unhappy as this carbon. So when you are happy, then what is the point of attacking on someone? You attack on someone when you are unhappy. Therefore, nucleophilicity of this is less than this ion because of difference in the hybridization. I write here, he is happier. He is not ultimately happier, he is happier than this. Just like you are not ultimately happier, you are happier than your neighbor. One more. CF3C minus and a CCl3. You are not able to see. Wait. CF3C minus and CCl3C minus. So if they ask you which of them is a strong nucleophile, and immediately with instantaneously looking at fluorine, considering its electronegativity, you may conclude the nucleophilicity of CCl3, nucleophilicity of CF3. Wait. Let us just change the question. CF3 minus and the CCl3 minus. And which of them is the best nucleophile? That's the question. Which of them is a best nucleophile? So if I write this structure, fluorine, this carbon has a negative charge, and chlorine Cl minus negative charge. By looking at the electronegativity, since electronegativity of fluorine is greater than the chlorine, you may think that the electron density is effectively withdrawn by the fluorine. The electron density is taken by the fluorine. The electron density is sucked by the fluorine. Therefore, this is the better nucleophile than this. But always what appears superficially is not truth. In order to understand the truth, you have to dig little more deeper with intelligence. So this chlorine atom has a 3d empty orbital. This chlorine has a 3d empty orbital. You know there are 5 empty orbitals in chlorine. Those empty orbitals have resonance with this negative charge. Therefore, in this molecule, p pi, d pi resonance is there. The electrons in the p orbital of carbon spread themselves, diffuse themselves into the d orbital of the chlorine, and that is called d pi p pi resonance. Due to that resonance, this negative charge is not much available. It is distributed among the pockets of 3 chlorines. So therefore, nucleophilicity of CF3 minus is greater than CCl3 minus. Here, if you try to figure out the answer based on the electronegativity, you fail. You need to figure out the answer based on the resonance. The orbital of the empty orbital of chlorine allows the diffusion of electron density from carbon. Therefore, this electron density is not much available. It is dispersed, it is diffused, it is transferred. Therefore, CF3 minus is a better nucleophile than CCl3. So we have seen three questions. We have seen three questions. Now we happily get into the other question. That question goes like this. NH2OH and NH3, what is their nucleophilicity order? NH2OH and NH3, look at, nitrogen has little cute lone pair, nitrogen also has little cute lone pair, since both of them are nitrogens. Now question is, which of them has more tendency to donate the electrons? Which of them have more tendency to donate the electron? If we look this hydroxyl element NH2OH, due to its more electronegativity, this oxygen can pull the electron density, from nitrogen. Yes, powerful always exploits the powerless, rich always exploits the poor, power will always exploits the powerless, not directly, indirectly. Therefore the availability of lone pair here decreases. Here the availability of lone pair is not influenced by any. Therefore nucleophilicity of hydroxyl element is less than NH3. Nucleophilicity of this is less than NH3. So get into the next question. Carboxylate ion RC double bond O minus and sulfite ion RS double bond S double bond O minus. Which of them is the best nucleophile? Look, oxygen is the donor here. And this oxygen has a resonance with the adjacent oxygen. This oxygen also participating in the resonance. But the number of resonating structure, both of them are equivalent resonating structure. The negative charge here is ultimately transferred to the other oxygen. The negative charge here is ultimately transferred into other oxygen. So the electron density is dancing between two oxygens. Electron density is migrating between two oxygens. Therefore, this is also equivalent resonating structure. But this has more resonating structure. What does that mean actually? It means in the reality? The negative charge is far more dispersed here than the negative charge dispersed here. The negative charge is less available here than this one. Therefore, carboxylate ion is a stronger nucleophile. Nucleophilicity of carboxylate ion is greater than sulfate ion. Due to the more number of resonating structure, this is a weak nucleophile because of electron attraction of hydroxy group here. And this is more nucleophile because of less number of resonating structure. That's the next question. If you get into the next question, a simple question, and the last question, SH minus, OH minus, H2O, CH3, C double bond O minus, and phenoxide ion PHO minus. What of hydroxide, sulfide, and carboxylate and phenoxide ion? And they ask you what is the nucleophilicity order? Oxygen is the donor, sulfur is the donor, oxygen, sulfur belongs to the same family. Down the group, nucleophilicity increases. Therefore, ultimately, SH minus has the highest nucleophilicity. And OH minus H2O, here resonance is possible, here equivalent resonance. Due to equivalent resonance, nucleophilicity decreases. Therefore, here also resonance is possible, but between these two there is no resonance. Therefore, SH minus. Next comes OH minus, followed by, you must remember, a neutral nucleophile is always weaker than the charged nucleophile. A neutral nucleophile is always weaker than the charged nucleophile, and between these two, because of equivalent resonating structure, it is a weak nucleophile. Therefore, PHO minus, followed by CH3, C double bond O minus, and lastly comes water. So these are the questions on nucleophilicity and basicity. Go through the lectures, go through the questions. If you still have any doubts, kindly let me know in the comment section. I try to clarify them. Yes, here this is a neutral nucleophile, and this is weak nucleophile because of equivalent resonance. This is a weak nucleophile because of more number of resonating structure. This is a weak nucleophile because of electron attraction of oxygen. Powerful is exploiting the powerless. So these are the questions, and this is about the nucleophilicity and basicity. I hope you do not have any problem to solve any question after listening to this lecture, and be happy and just be excited about the life. That's all for the day.